Alright, so in this video I'm going to go through a couple of examples of calculating probabilities based off normal distributions, and I'm going to do this using manual methods, i.e. using a table. So we're told to assume that a population of people has an average height of 170 centimeters and standard deviation of 10 centimeters. So we're asked what is the probability that a randomly selected person will be, and we're given a few different conditions that we need to look at. So before we get to that, let's quickly make a diagram of what our situation is. So we're told that we have an average height of 170, so that's going to correspond to the mean, which we're going to call mu for the symbol, and standard deviation is 10, so we're going to call that sigma for the symbol there. So when we draw it, alright, I'm going to have an x-axis, and this is going to represent all the different heights of the people in my population. Okay, and usually we give that the variable x, okay, so the thing that you're actually measuring. So if we then plot out what the probability function looks like, something like this, which is why it's called a bell curve, and we know that the mean value occurs at the center because it's perfectly symmetric. So this here is mu. So I'm just going to make a little note that when we're dealing with x, the standard deviation is equal to 10. So now let's look at this first question that we're asked. So we need the probability that someone's between 170 and 180 centimeters tall. So 170 is already marked. Let's pop in 180 here. So what we're going to find is that to calculate the probability, we need the area under the curve. So this area in the zone we're interested in. Now, in order to do this using our tables, what we need to do is convert from x, our people's heights, into z, which is like the normalized distribution. So there is an equation to convert. This one here. So z is the z-score, which is what we're going to be looking for. X is the observation that you're interested in, so whatever height that might be. Mu is the average, so that's going to be 170, and the standard deviation we've got as 10 for our population. So 170, if we want to convert that into a z-score, that one's really easy. Because it's the mean, every time you convert it into a z-score, it should go to 0. And you can kind of prove that with the equation. If you set x to be 170, mu is the average, which is also then 170, so you're going to get 170 minus 170, which is going to go to 0. Okay, so if we pop that in terms of our z scale, this corresponds to 0. If we now go for the 180 and do the same thing, so we can sub it into our formula this time. So 180 is the x, or height, that we're interested in. The mean is 170, standard deviation is 10. So if you type that in a calculator, it's going to work out to 1. So that's what this point corresponds to on our z scale. So now it just becomes a case of needing to calculate the actual probability. So we can write this out. So the probability that our height is between 170 and 180. So we can write that like this mathematically. And then because we want to convert it into z, right, we said 170 corresponds to 0 on the z scale. And 180 corresponds to 1. So these are now equivalent. So this z-score is what we can look up in the table, and I've got it right over here. So this table is providing us with the probability distribution, probability in terms of the area under the curve for the blue highlighted zone. Okay, so it's basically from the mean value all the way up until some cutoff, which we're calling little z. So how we read this table is that the bolded stuff here, that corresponds to the actual z value. All of this stuff inside the table that's not bold corresponds to the area under the curve for that region. So in our case, what we're interested in is the probability from a z-score of 0, which is the middle, all the way up to 1. So that's going to be our cutoff. So we need to set little z to 1. So on this table, the first column is kind of giving you the first part of the z-score. So if we're interested in 1, that would be this bit. And then all of these are like the second decimal. So if we want 1.00, that means we need to pick up this column intersection. So it corresponds to like this value here. So let's pop that in. So the probability is 0.3413, and if you convert that to a percentage, it's going to be about 34%. Okay, so that's the answer to this one. The probability that you're between 170 and 180 centimeters tall would be just 34%. Alright, so the next one that we need to calculate is the probability that you're between 175 and 185 centimeters tall. So what I'm going to do is just ditch some of this stuff that we've already used, and we're going to make a new thing. And let's get rid of all of this. Alright, so our points of interest this time is 175 and 185. So that's going to be here and here, I'll guess. So we need to again find the region in between. So this part in here. And to do that, we're going to need to convert this over into z-scores. So we already decided that the mean here was equal to 0. So now we just need to convert these other two of 175 and 185. So again, using our conversion, start with 175. So this one is going to go to 0.5, I believe. So let's mark that in. And if we do the same thing for 185, I think that one goes to 1.5. So that's this one here. So now that it's converted into Z values, we should be able to look it up in the table. So writing out our probability statement, we want the probability that someone is between 175 and 185. And when we convert that into the Z stuff, it's between 0.5 and 1.5. Alright, so this one is a little bit trickier in terms of looking up in the table because we don't have these random kind of cutoffs in the table. All the table is ever going to tell you is what happens between the mean, alright, or a z-score of 0, up until some other point. So how we can get around this is we can kind of take the difference between a couple of areas. So as a first step, if we figure out the area between the mean here all the way up until 185, alright, let me colour that in a different colour. Alright, all the way in this bit here. So we could write that as the probability from, in terms of Z, I'll go with, from 0 to Z to 1.5. And then, if we take away this other little bit in here, all that we're going to be left with is the blue bit. So we can write the grey bit as the probability of being between 0 and 0.5. Okay, this bit here. So let's go and look those up in the table because we actually can. So 0 to 1.5. Alright, so that becomes our cutoff. So looking it up in the table, 1.5 here. Again, we want our second decimal to be 0. So it's going to be 0.4332. Minus this one here, it's from 0 to 0.5. So 0.5 is here, second decimal is 0, so that's the one we want to pull. So 0.1915. And if we type that into a calculator, 0.2417. So that's about 24% chance. So if we come back and answer the question, that means the probability of being between the 175 and 185 centimeters tall is about 24%. Alright, so the last one is we're looking at what happens in terms of the probability for being less than 140 centimeters. So let me again just erase everything that I had. Alright, so I've gone back on my diagram, and what we're interested in this time is 140 down here. So if we want less than, it's going to be the bottom side of this curve from 140 all the way down to nothing. Alright, so In order to do this, again, we need to convert over our point of interest, which is 140. So let's substitute it into this. So 140 minus 170 over 10. So this is going to be negative 30 on 10. So that's going to go to negative 3. Now don't be alarmed that it's come out negative. All that's telling you is it's below the mean, all right, or on the left-hand side of the mean. So the z-score here is negative 3. The mean was 0. All right, and just a reminder that that's in terms of z. So now we can write out our probability kind of statement. So we want the probability that someone is less than 140. So that's going to be x is less than 140. If we convert this over to z now, so we've said that 140 is equal to negative 3 on the z scale. So it's going to be the probability that z is less than negative 3. If we're using the table to solve this, we're going to need to do a little bit of manipulation to get it in the form where we're looking at it between 0 and some other cutoff point. Okay, at the moment we kind of have the opposite, where we don't want 0 to the cutoff point, we want the other side of it. So we can do a bit of manipulation. If we know that the entire area under the curve is equal to 1, that means half of the area under the curve, so say this side backwards, is going to be equal to 0.5. Okay, so this is everything all the way back, is 0.5. So if I then work out what's in here, this part, the area of that, it's going to be, I take the whole half, which is 0.5, minus the red bit, should leave me with the blue bit, and that's what I really want to know. So I'm going to write in here minus the probability that our value is between 0 and negative 3. Probably should write this as negative 3 z0, so it's in the right kind of order, smallest to biggest. Alright, so this is kind of backwards to what we had before, where we were looking at kind of the positive side of the diagram, but that's not too bad. Since the whole thing is kind of symmetric, if you look from 0 to negative z, it should have the same area under the curve as 0 to positive z. So we can just swap that over if we're keen on that. So this is going to become still 0.5, but it's going to become minus the probability from 0 to z to positive 3. Positive 3. So let's figure that out from the table. So we need to figure where 3 is. It's going to be pretty low, 3. And again, because we want the second decimal to be 0, it's going to be the first column that we take. So 0.4987 is what we need to put in here. And we still have the 0.5 minus. So this is going to work out to 0.0013. So it's a very, very small number. If we convert that into a percentage, it'd be the same as like 0.13%. So super small. So that's the answer to this one, 0.013. I invented an extra 0. 0.13% is the probability that someone's less than 140 centimeters. So that's all there is for this video. I'm going to verify these calculations in the next one using Excel. So if you're interested in that, tune in.